We'll start with our first panel, Sustainable Built Environment. And Elise Alsucker will again join us as a panelist. And yeah, let me do that. Oh, wait, let's stop. No spotlight. Okay. So Elise Alsucker will again join us as a panelist. And then the two other panelists, they're also joining us remotely today, are Esther Obonyo and Juan Pablo Gevaudan. So I will actually let them introduce themselves, but Esther and Juan Pablo are both from Penn State. Esther is an associate professor of architectural engineering, and she's also directing the Global Building Network at Penn State. And Juan Pablo is an assistant professor of architectural engineering. So the way that this will work is they will begin by talking about their research briefly, and then I will be chairing this panel. I will ask them questions. Then we will ask the audience to ask them questions, and they will answer both the questions from the audience on Zoom, the in-person audience, and our questions. Okay. Esther, Elise, can you begin by maybe introducing yourself very briefly for people who just joined us now? Maybe there might be people who missed your first presentation. So can you briefly talk about your research, who you are, and yeah, thank you.
Right. So in one sentence, I'm Elise. I did my PhD in Belgium at the University of Brussels about mycelium materials. So I investigated in a very comprehensive way how to produce those materials and what their biological and mechanical properties are. And currently, I'm a postdoctoral researcher at Newcastle University at the hub of biotechnology for the built environments. And I'm involved in the research group of Martin Date Robinson, working on living mycelium materials. And my goal is to create leather materials which can self-heal when they have a crack or a damage.
Thank you. Esther, would you like to introduce yourself, talk about your research in relationship to sustainability in the built environment?
Yes, okay, sure. Thank you so much for having me. And I apologize for not making it in person. I'm on the tail end of a COVID infection, so I needed to stay to make sure everybody is safe and not at risk because of me. So relevant to this topic, my work is usually prefixed by two words, low income housing. I'm very interested in looking at issues of affordable housing and understanding the factors that are contributing to the perpetuation of this problem in different parts of the world. So I work in the global north, Florida, Pennsylvania, and global south countries such as Kenya and Tanzania. My interest in biomaterials was driven in part, is focusing on the fact that they are more affordable, they are locally resourced, you're eliminating transportation costs, they are better suited to the climate from a perspective of extreme weather events, whether it's extreme heat, but then we're also being very humble and modest and saying that we know that they're susceptible to moisture damage. So we are looking at ways of addressing some of these performance constraints. We are also interested in market building. Now, how do we increase the market share of the biomaterials? And we are using entrepreneurship, engineering entrepreneurship approach. We are interested in equity and social justice, again, connected to all these different elements. Can we make the building more affordable? Can we make the building more durable and resilient? Can we make the building work in terms of resisting extreme weather events? I'll leave it at that for now.
Thank you. Thank you, Esther. Juan Pablo, would you like to introduce yourself?
Yes. Hey, everyone. My name is Juan Pablo. Thank you so much for having me today. You can call me JP, though. That's much easier. And so our research in the Responsive and Adaptive Infrastructure Materials Lab really focuses on mapping the sustainable cement chemistry of concrete materials. And we do that so that we can point areas of the map that can satisfy material properties for different civil infrastructure or building projects needs that the infrastructure owners may have. In addition, we're also interested in mapping the degradation performance over time, because as we know, and we'll talk about in the panel, sustainable materials need to be durable in order for them to be a good solution over time. So we're really interested in mapping also the degradation performance over time so that we can tell infrastructure owners and clients that their materials are going to last in the field.
Thank you, Juan Pablo. Okay. So I will start with a few questions. And the first question is, how do you think biomaterials, such as mycelium-based composites that we saw in Elise's presentation, when used in architecture, engineering, and construction industry, can play a role in addressing the environmental challenges? And then there's another question that follows. Are biomaterials necessarily sustainable? So who wants to go first? Elise?
Yeah, I can start. I would even say it's climate emergency. It's not climate challenge anymore. Yeah, the question is really complex because this climate emergency is also very complex. So whether those materials can form an answer, maybe partially, I don't know yet. We need to see how they are made at scale. They do answer, I think, some challenges that we see with, for example, fossil-based materials in terms of reduction of waste at the end of their use. So the materials are compostable in soil or in any kind of compost. So in that sense, they wouldn't form such an environmental problem as some of the plastics or fossil-based composites that we see being used in construction. Their production is circular because they are also made with, they are grown with a material which on a waste stream. And the process is, compared with many other construction materials, low energy process. But I think whether this kind of materials are sustainable also depends on the scale at which we will use them, and the quantity we need to replace the current fossil-based materials, because plastic in itself, it's not an unsustainable material, right? It is the way we use it that is very unsustainable, the way we dispose of it, and the way that we extract it, that is unsustainable. So it's more about the process, the production process, and the process during its lifespan, which forms the environmental challenges. And with mycelium materials, I think we might fall into the same kind of pitfalls as we have fallen with plastics, or as we have fallen with biofuels. If we start to scale it, if we start to harvest forest or harvest fibers from agricultural fields, which we need to produce food, but we would need those fields to create materials, I think we will also have sustainability problems. So yeah, I think it's more about how sustainable the process is rather than how sustainable the material in itself is. And mycelium material form a nice story to that, I guess. Yeah.
Thank you.
Yeah. Benay, if I can add something to that, I think from our perspective on sustainable cementitious materials, we can learn something that can be applied to maybe mycelium materials as well, in that really sustainability from our perspective calls for a toolkit, right? Where we're thinking about different materials as different tools that we can use for different projects. So instead of building or relying on a few formulations of a specific material, such as the petroleum-based materials that we have been talking about that have environmental issues, we can diversify our use of one particular material with different alternatives that for different projects or for different product needs may work better in those cases. So I really like that idea of the toolkit, and I think it complements a lot of what Elise was saying.
And how does this toolkit look like? Can you elaborate a bit more so that I understand?
Yeah, definitely. So how that toolkit looks like is something that I think we're all developing, right? As we work more on maybe mycelium products, or from my perspective, when we work on a type of cementitious material called alkali activated materials. And once we start to craft those formulations to have specific material properties that are advantageous for specific applications, then we can start to say, okay, this material formulations, they're really good for maybe building insulation applications. And this material formulations over here, we tweaked maybe, fibers that you were describing, or like that decomposition of the fibers balance, right? To optimize mechanical properties, maybe those work better for other building applications or product applications, such as packaging and so forth, right? So it's almost like categorizing different formulations for different applications, and that's something that in our lab we've been starting to do, specifically in realms such as nuclear waste immobilization, but in other realms such as historical preservation, right? So creating mortars that are low CO2 in their production, but that can actually allow us to preserve our historical heritage in our buildings. So hopefully that paints a picture of maybe how that toolkit looks like.
Yeah.
Yeah.
Maybe to add on top of that is that with the development of new materials, it's often a challenge to know their life cycle, because we are like in these early stages, we as researchers have difficulties of developing this life cycle assessment, because that's often done at an industrial scale. So I think in that sense, with the toolkit, we also need like reliable tools to do those life cycle assessments, or maybe oblige the companies to come up with the life cycle assessments of those new materials, and to really prove that the whole process is indeed sustainable, because often there is no data, because the process is often patented or an IP secret. So for us as researchers, it's often difficult, to understand in every stage of the process whether the production itself is sustainable. And then I'm not even talking about the life cycle of the material itself. What your researcher is more about, I think, on the longer term. Yeah.
I think you bring up some really fascinating points there, and specifically when we're starting to talk about like the end of life aspect that I think you touched on, and specifically comparing it, plastics as we use them now to mycelium-based materials. The end of life aspects are so critical, right? But they're also the ones that have the most uncertainty, because we're predicting out maybe 50 years, 25 years, depending on the product. And we don't know what the trends are going to be, or like what the technologies are going to be 50 years from now. But having thought about end of life from the conceptualization of that material, from the design, from the formulation, initial part of that material is critical, because it at least provides a solution for that end of life aspect.
Yeah.
So, yeah.
Thank you, Elise and Juan Pablo. I'll proceed with the second question. I think this can be answered from all of you. So, how do you think your research and or teaching advance the Sustainable Development Goals? And maybe I can say how Penn State embraces the concept of sustainability. For Penn State, the concept of sustainability is broadly defined as the simultaneous pursuit of human health and happiness, environmental quality, and economic well-being for current and future generations. So how do you think your research like addresses or your research and in your teaching, you advance these goals, these Sustainable Development Goals? Esther, would you like to start?
Sure thing, I can go first. So I'll build on your definition, the definition that you've quoted for Penn State of pursuit that zeroes in onto the pursuit of human health, happiness, environmental quality, and economic well-being. So I'll start with the human health. The extraction, the unsustainable patterns of extracting materials for buildings is creating, this is a fun fact, it is creating what my collaborators in the College of Medicine call maternity wards for mosquitoes. So vector-borne diseases are on the rise because of very many things, including extreme weather events, but then also because of the way materials that are being used for our building systems are being extracted, we are damaging the landscape and creating places where we have these small ponds of water. So some of the research that we're doing is in collaboration with people in the medical side to try to understand how the processes can be made to work for both the environment and protecting human beings from diseases. I'll build on that a little bit. We are looking at materials such as earth and masonry that have thermal stability. Across the world, it's getting warmer, it's getting hotter. We know that these materials are amazing in terms of lowering the indoor air temperature. Extreme heat can be linked to so many diseases. They can exacerbate existing conditions. They can also create new diseases where others, among people who are originally not sick. Biomaterials are amazing, as I said, for addressing some of these stressors and triggers. At present, it is estimated that 1 in 8 people around the world live in slums or in slum-like conditions. The materials that we are investigating that are based on use of biomaterials that are locally resourced are more affordable. They can be connected to cottage industries. And we believe that if we continue to work synergistically with community sector organizations and government agencies, we can start to make a dent with respect to transitioning these houses to buildings that are more appropriate and adequate. There are 70 million people, it's estimated that we have 70 million people who are displaced from their homes, and every year, more than 70 million. A lot of the work that we're doing is looking at how to make sure that these biomaterials, when they're translated into building systems, do not result in structural collapse. And then the final piece linked to the economic well-being. We are big on engineering entrepreneurship and entrepreneurship in general. We are linking our work to startups. We are linking them to the creation of jobs, the creation of new industries. All these activities have a very heavy connection with student-centered learning. We've done a bunch of things. We've created international research experiences for more than 2,000 students. On a regular basis, we have anywhere from 12 to 20 capstone students working on various aspects of the humanitarian material challenges that we've identified. We have graduate students, we have individual undergraduate research students. I could go on, but reach out later on and I'll be happy to discuss the details. Thank you.
Thank you, Esther.
Yeah.
Juan
I
Pablo?
can jump in. So one of the things that we've been doing in the architectural engineering department is to really bolster our sustainability educational programs. So one of the classes that I teach is on sustainable materials and structures, and just talk about a little bit about the pedagogical challenges when we started talking about sustainability. We all know sustainability is a very systematic, complex system that involves global economies. So that requires this systems of systems thinking approach that presents a very interesting pedagogical challenge, especially in engineering curriculums, because we don't necessarily introduce those systems thinking skills at any other a scale before really like the last year with this sustainable materials and structures course. So, you know, broadening the engineering mindset to start to tackle, you know, how to think about sustainability and how to define sustainability in the built environment really presents really interesting challenges that well, they're fascinating. So that's something that we've been trying to tackle and encourage our students to understand and apply those to life cycle analysis frameworks. And I think we talked a little bit about maybe some of the data that we need, and then whenever we're analyzing industrial products, like, you know, we were talking about, the industries may have a lot of proprietary information that then really prevents a big roadblock in how we assess the sustainability of different products or materials or even structures. So how to deal with these roadblocks, how to estimate like data to really quantify the environmental impacts of materials and structures really is something that, at least from the educational side, is something that we're tackling in our coursework.
Thank you, Juan Pablo. Elise?
Yeah, I'm quite young in my academic curriculum, so I'm not yet into professorship like you guys. So it's talking about education and how we implement it like globally as a research group. I can just talk about how I've experienced it in the 2 different universities that I was involved in. So in Belgium, in Brussels, I found there are some courses which includes sustainability, circularity, but it is still very minimal, and it's mostly led by the interest of the professor, him or herself, to actually talk about those subjects within the academic, within the architectural engineering group, for example. And then at the hub of biotechnology in the built environment, so at Newcastle University, where I'm now, we are not that much involved into education, but all of our research subjects include those sustainability goals. And I actually, maybe it's a bit radical to say, but a research line which doesn't include at least one of those goals actually can question itself, because it is actually very, very important at this point. And so within the hub, there are research topics about using human waste as a generator of electricity, for example, or other kinds of energies. We work with all different types of materials like cellulose. We also use bacteria to cement sand together. So it's kind of exploring all those new biotechnologies. Yeah, I don't know if I actually answered the question about the sustainability goals, but yeah.
I think this is great. Are there any questions from the audience? In person and on Zoom, let me check. Okay, there's a question about fungal biomaterials on Zoom, but I will keep it for a later moment.
I can maybe answer it later on in the chat.
Okay, that would be great. Okay, so if there are any questions, I can ask more questions. So again, related to the going back to a sustainable built environment, how would you define a sustainable built environment? Like what makes it sustainable, and in which ways do you think a sustainable built environment can address the challenges we're facing globally? And what do you think are the main challenges in the architecture, engineering, and construction industry towards achieving a sustainable built environment? So 2 questions in one, like what are the challenges to achieve a sustainable built environment? And then once a sustainable built environment, like what is it first? And how do you think it can address the challenges we're facing globally? Okay.
Yeah, I guess I can start us off.
Sure.
So something about the definition of sustainability, something that maybe I missed in my earlier answer, is that sustainability really is a 3-pillar concept, right? So we often talk about the environmental impact. And when we talk about the environmental impact, we're mainly concerned with greenhouse gas emissions, so CO2 being the primary one, but methane and others also being greenhouse gas emissions. But then there's also 2 other pillars that we tend to maybe overlook, although Esther pointed one of those out, which is the social equity component being one of them, and then the economical component being this 3rd one there. So really, when we're thinking about sustainable materials, we really should be thinking about these 3 concepts, these 3 pillars: environmental impact, social equity, and the economics behind the solution. So that, applying, going to the second question there and applying it to that second question, a built environment really that is sustainable really will capture all 3 of these components. And in every solution that we are describing, whether it's a material, a product, or a structure, it really must be targeting or addressing these 3 components in order to be a truly sustainable solution.
Thank you, JP. I'll jump in and I'll just make 3 points. There's 3 questions, 3 examples of questions that underpin the work that we are doing to try to, first of all, identify the challenges that could be addressed through a materials and building technology approach. And the first one is really, how do we use our resources efficiently at the practical level? Because of the focus in the humanitarian, low-income, vulnerable population space, we are recognizing things like material scarcity. So for example, we are running a student competition in Zanzibar right now with Tanzania, in collaboration with our Tanzanian partners. And the thing that's come up a lot is there's a scarcity of sand. I could do a similar thing in Kenya, and the issues that's gonna come up is scarcity of lumber. From a building perspective, if you don't have, you don't have easy access to lumber, you don't have easy access to sand, I don't know how they're going to bridge the affordability gap. So some of these practical questions, they're linked to resource efficiency because our current consumption patterns and historical patterns of consumption have resulted in resource depletion. So we are not just looking forward, but we're also trying to address the impacts that are already being experienced right now by the people who are at highest risk. Secondly, how do we make the economic opportunities that are associated with the entire value chain of buildings work for everyone? I made reference earlier on to entrepreneurship, startups, and jobs, but also at the practical level, thinking about issues of scale. a lot of the biomaterials, we got this from the first keynote speak this morning, a lot of the biomaterials are still in the pilot case study phase. We are producing in small scales. We are not tapping into the economy of scale. And part of the reason why the market penetration is happening very slowly is because of the production scale. So we want to ask those questions and we want to find answers to them. If we are going to compete with the conventional building materials, then we need to think bigger. The last question is, how do we make biomaterials help us to advance human rights? There is a basic problem there of lack of access to adequate shelter. There is a deficit of affordable housing units across the world. That's a human rights issue. How do we embrace this moral lens that allows us, again, to both fix the problems that exist in the system right now because of the history of marginalization and exclusion, while also bearing in mind that we are chasing a moving target. Every single year, the gap keeps widening. I think I'll stop at that. Those three things for me.
Thank you. I mean, I think you answered also another question that I had for you specifically, Esther. How do you think, where do you think like social issues fit in this pursuit of sustainability in the built environment? And I think you already answered this question in some of your answers, but do you have anything else to say about that?
Yes, right. I think I will add this because I didn't say it explicitly. While anyone can be living in housing conditions that threaten the health, our well-being, and also our productivity, performance, comfort, etc., we are all impacted. It's getting hotter right now. A month from now, those of us in houses with no air conditioning will be impacted adversely. So we are all being impacted by the problems, several of these problems. However, because of the history of injustices and marginalization, we have demographic groups that are at a higher risk and that are being hardest hit. So this includes low-income families, low-income individuals, single-parent homes, racial and ethnic minority groups, renters, children, older adults, people with pre-existing health conditions, millions of people in the global south. We need the social lens to make sure that the existing impacts are taken into consideration as we develop the market for these biomaterials. We need to embrace the social science perspective to help us ensure that we do not contribute or compound the existing injustices and marginalization. It's a human rights issue, it's a moral issue, it's a legal issue. It's our responsibility.
Thank you. That's a great answer. We have a question from the audience. So
yeah, so I was just curious, is there any example of, it could be anything, it doesn't even have to be architectural engineering, that is a system at a large scale that does meet all of the three pillars of sustainability?
Maybe this is a question for you, JP, right? Because you clearly define the three pillars.
Yeah, absolutely. I'm thinking, because that's a great question. One example could be the push right now for mass timber as a structural material, and particularly, it's being poised as a carbon negative material. And I think we have maybe a question about that in the chat that we can dive into further. But the idea of carbon negative materials, and specifically mass timber, is that, first of all, timber is an abundant resource available in the US. So economics are there to provide more timber and more applications of timber in construction. From an environmental perspective, given that we have sustainable forestry management practices in the US, mass timber can be a carbon negative material, which means that it's going to absorb CO2 from the atmosphere and it's going to store it in the wood material itself, right? And the third, in the social equity component, that's where we're not doing so well. And that's where we need a multifaceted approach to really address social equity issues, because what's happening right now is that the sustainable solutions are being constructed and are being put into realization. However, they're not being fully available to the wide demographic, and that's a socioeconomic demographic in our nation, right? So sustainability tends to be only an option for those who can afford it, which is the wealthy population sectors, and that's the main issue. And as Esther talked about, it is a moving target, and one that, in my opinion, I don't think we have done a very good job to make these solutions and new materials, specifically when we start to talk about carbon negative materials, available for the wide sector of the population. So to answer your question briefly, I don't think we have that holy grail material at the moment, but it's hopefully something that we can get to.
So if I may jump in, I like JP's answer, and I want to connect back to a comment that JP had said earlier on about the system of system approach. And I'll highlight an example. A few years ago, I visited Auroville in India, and that was because the world's most renowned earthen architect is there. He moved from France to Auroville. And I flag this up because of the concept that's been used within Auroville. I know that a few people have visited there, including DK. I don't know if he's here right now, that it's a community. So he was there because of spiritual reasons, but because he was there, he ended up setting up an ecosystem where he's teaching people how to use a locally available material. He is creating jobs. He has a company, an outfit that goes around and does actual work, and they hire people. And there's that very nice narrative that comes out of implementations such as those ones, because he's promoting the use of a material that is environmentally sustainability. He is linking it to economic development and entrepreneurship and startups. He's teaching people. He has students of all ages. And then finally, as far as Auroville community is concerned, Satpren Maini is contributing to the social health and well-being of the community. And he's not the only one. There are several other people in that community who have embraced that model. So I think if we start to think about our interventions at all these multiple scales, the material science scale, the building brick scale, the building system scale, the home, the community, the society, and we are operating as part of a well-coordinated network, we can replicate this model in several other places.
That is a great point. And just one thing that just comes to mind, inspired by what Esther just talked about, is right now we do have, we're seeing a big push in the research global community for earthen-based work or earth-based materials. And as you know, Esther is pointing out, is really the need to use local materials that are abundant in different geographies around the world. And clays tend to be the most abundant material in the world. So it's how do we use clays? How do we use earth-based materials to build in a way that actually also replicates some of the endemic architectures that we have seen in many parts of the world, because clay was one of our first building materials in the history of humanity. So, you know, there's a big push for earth-based materials, and that could be potentially a good material that combines all the three pillars of sustainability.
Maybe to quickly jump also on the different ideas that are given here, I'll take an example that I heard last week in another conference, which is that there is a city in Sweden, Malmö, which has decided to be carbon negative by 2030. So that's in 8 years, right? Quite soon. And to do so, they are also jumping on the timber, structural timber idea, to have all the new buildings being carbon negative. They will basically have to cut off their whole forest and Sweden has a large forest. So I think we have to be mindful as well that abundance is limited at a large scale for any type of material, whether it is sand or wood or clay or yeah, oil. Yeah.
Thank you.
Yeah. Sorry, I feel like I'm talking a lot, but but I think that Elise is bringing a really fascinating point, and I think one of the biggest advantages when we start to talk about mycotechnologies or fungal biomaterials is that they're renewable, right? So we don't have to rely on these non-renewable feedstocks of materials when we talk about you know, sand or clays, and even to some extent timber, because that really depends on the sustainable forest management. So I see that as a really exciting possibility with fungal materials.
Exactly. I think the intention of those of the city of Malmö in Sweden is actually really good, but then, you know, by taking the decision, which is too soon, they end up in a wrong kind of process, and we might see those kind of processes happening in other parts of the world as well, where there is no sustainable management of the resources.
Okay. Zubaide has a question.
Yes, thank you all three. This is a great conversation. Esther, I really wanted to go back to one of the many important points that you made, and I'm paraphrasing here, but you in essence said that at our institutions of higher education, for example, where we're focusing on fundamental science, engineering, architecture, I'm trying to be inclusive here, questions, right, to make these bio-based materials a reality. We need to be doing that in concert with and grounded in social justice and equity positive outcomes. In order to do that, Esther, who else should we be engaging in our institutions and outside?
All right, yeah, thank you. That's a good question. So I was very excited actually this year when I noticed that the organizations, federal agencies, including the National Science Foundation, are beginning to amplify co-producing and working collaboratively with the impacted communities. So there are very many programs where now we're being asked, can you explain how you are engaging with the vulnerable populations, marginalized populations throughout the entire research, not just from, you know, the traditional models of user requirement capture, and then at the very end, you come back and you do customer satisfaction, basically getting feedback for your validation. So I think one of the questions that we need to ask ourselves to be able to respond to your question, Zubaida, you know, who has those skill sets? And I think it's everybody. I know that's a very generic answer, but I give you examples of places where I'm looking for people to challenge the questions that we're asking. And this includes the Rock Ethics Institute. Is it an easy conversation to have? It's not an easy conversation to have, because the way philosophers, for example, think, or people who are calling themselves ethicists think, is different from how we think. I try to sit at the intersection of disciplines, but at some point I will default to my training and my background. So I think it's just being very mindful of what is in our blind spot, that at the end of the day, we are making a lot of assumptions from a very technical perspective, whether we are in, you know, architecture, architectural engineering, and all, you know, material science and all the other disciplines. But traditionally, the way I'm learning, philosophers, people in history and geography, the way they question things start with a lot of room for ambiguity and uncertainty. And it's the uncomfortable space. So I would say I'm at the point in my life where I'm saying, if I'm too comfortable, I know I need to be talking to somebody else so that they can make me uncomfortable. And that is how we create the void for them to occupy fully. I will finish by saying that historically, we have used this phrase and said, we want to work with social scientists, but no, really, we don't really know how to work with social scientists. Most of the times we start with a hypothesis and then we go and recruit them. what I'm learning from them right now, come with a blank sheet of paper and let us educate you on the type of social scientist or someone from humanities that you need to engage with. I reach out to people, including my brother, who's in English literature, because sometimes the problem is communication, and our choices of words result in the synergies with the marginalized communication, with marginalized populations not happening because we are not communicating in a way that connects to them. So I am very comfortable with giving them my thoughts and letting them shred it to pieces and just telling me that you need to start all over again. So I'll just say, work with everyone and be uncomfortable, be comfortable with being uncomfortable, and all the other disciplines will show up. Actually, sorry, I can't believe I forgot to say this. Gender dimensions, those are things which have been neglected within our community of practice. We have very few women from the communities participating in our conversations historically. If we are going to learn how to work with marginalized populations that have a high concentration of women, we need people from gender studies.
Wow. It's really inspiring.
Okay. There are some questions on chat, mostly related with fungal biomaterials, but there's also a comment by Drew Pedrick. He's saying these discussions are wonderful, inspiring, and absolutely necessary. Thank you to everyone involved. I'm especially excited to hear the discussions around social issues and the impacts of an outdated view of the planet as resource. And he wishes everyone the best in their work. Okay. Are there any questions from the audience? Okay. I have a question, maybe one last question before we give a lunch break. And it's about how, like, Esther, we know that you initiated lots of interdisciplinary collaborations during your PhD that did not exist before. Like, you collaborated with architectural engineers, biologists, and you started these conversations from scratch. They did not exist. How challenging was that? And how challenging was that to create that conversation between different disciplines? So this is a question to you, and I think Esther and Juan Pablo, you can also talk about the interdisciplinarity of your research and who are the stakeholders. How do you initiate the conversations between them? And maybe we can start with Esther and then proceed with we can start with Elise and proceed with Esther and Juan Pablo.
Engaging the communication with microbiologists or with chemists, it started from the curiosity, just being curious to understand their field and understand their vocabulary. It's definitely not been easy because there are many technical terms that still today I still don't understand everything. And I touched upon it during the presentation. Is what allowed me to engage with them was having those students, the master students coming from those fields and working together, helped me to be very focused on, some aspects that I had no idea of. So usually what I would do is write out a master thesis topic on a specific project that I knew I would be researching in a year. And then they would kind of explore all the challenges, all the difficulties a year in advance of when I wanted to start the work. So then I already kind of could build on the knowledge that they gave me. And it was definitely not a kind of top-down teaching. I think I learned way more from them than I could give them, because I only could give them questions, and then they had to find the answers to them, and that allowed me then to to also engage with the professors and other people in the other disciplines.
Thank you. Thank you.
Yeah, so I can go next. I think my journey started with frustration. I'm a product of an industry-based PhD, and everybody was actually surprised that I finished a project, a program that was supposed to set us up to work in research and development practices in multinational companies, and I ended up coming back to academia. And the reason why I did that was because academic professions give us a lot of flexibility. We can ask questions. Yeah, I've learned along the way from people in entrepreneurship, for example, like ask 5 whys, like just keep asking questions. And within the academic environment, we can do this. In the private sector, when I was in the multinational company, people wanted quick wins. They want a return on investment right away. So I think it was recognizing that at a personal level, I want to be involved in things which are human impact oriented. Multinational companies do that for sure, but there's also, for very, very good reasons, there's this quick turnaround that is required. So coming into the university environment gave me an opportunity to start thinking about 30 years, 40 years from now, what would make me happy if I looked back? And when I started to engage with different people in conversations at that level, I was pleasantly surprised to see that people want to talk. When I show up and I'm not in a hurry, when I show up and I tell them, I'm in this for the long haul, I'm running a marathon. Yeah, where do you want to start? One of the tips that one of my advisors gave me earlier on in my career, he had spent some time looking at low-income housing in Kibera slums in Nairobi. And one of the things that he said was the first time he went to do research in the field, he got very little from the questionnaires that they were using. But then he stopped by a local restaurant, very small kiosk, for lunch. and he introduced himself, and over food, people actually started talking. So they told me right then that create this environment similar to what you guys are going to do in 5 minutes time, where there is food and people sit in this very informal setting. Food makes people relax and there's no hurry and people start talking. So a lot of the things that I've stumbled upon, I would use the word, it was a stumbling upon. We created the opportunity for the interactions to happen. We minimized communicating about the technical jargon. When we are in scientific conferences, we amplify the technical details. When we are outside that environment, we minimize all that and we start to ask questions, why? And also trying to ask people, what do you care about? Why do you need, I'm very bold now, I can even ask people, why are you interested in a relationship with Penn State University? And it's amazing, I get really good answers. Like, why are you interested in a professor who's in the College of Engineering? I'll finish by saying that an example, when I first visited New Kensington, I was invited to talk about a problem that's connected to materials, affordable materials, efficient materials for the roofing. I was very happy on the roof. Yeah, but when the people who are around me realized that I was willing to listen to them, they pulled me down from the roof. I use the word pulled me down because I wasn't sure that there was anything for me to contribute to the conversation that does not focus on the damaged part of the buildings, but they taught me. They told me that this is what you can do. Yeah, you're in an environment where our biggest problem is youth unemployment, youth who don't want to go to college, and maybe because they've not seen people who look like them who go to college. So I'm sharing this example to say that the vulnerable communities, the marginalized communities, community sector organizations that we collaborate with that have boots on the ground, they are willing to teach us. They are willing to teach us how to engage with them if we are willing. And the best part of it is they flip it around and they empower you. They tell you how you come in. They say, we need you because of the following things. You need us because of 1, 2, 3, 4, but we need you because of the following things. So I would just say, listening, being humble, and being willing to be uncomfortable, and providing lots of food.
Just to maybe round off our discussions and building on both what Elise and Esther said, multidisciplinary for us is essential when we're thinking about sustainable cementitious materials because we enjoy and we want to learn how different disciplines that are very much far from what we do look at perhaps similar or tangential problems as the ones that we see in the lab. So for example, just to give one example on 3D printing, that is the strength of a Penn State and something that we're working on to create sustainable cementitious materials for 3D printing. We have gone to the food sciences department because they deal with rheology for different food products such as chocolate and mayonnaise and ice cream, right? But understanding their unique perspectives on studying rheology of these different materials actually is very exciting for us to learn about, because it can open up new methodologies for testing our own materials or maybe solving some of the issues that we see in the 3D printing aspects of sustainable cementitious materials. So with that, I really think is both what Elise and Esther said, is maintaining curiosity and bringing your whole self into these curiosity-based conversations in the interdisciplinary aspects.
Thank you. Fantastic answers. So I think we can conclude the panel. So can we have a round of applause for our panelists?